Okay, so let's start looking at 2.7 nonlinear inequalities. And we are going to be thinking about some shading and interval notation and things like that when we're looking at our graph. And again, a lot like what we've been doing before, we are focusing on our x-axis and which part of the x-axis is actually going to be a solution for these problems. And this lesson video is going to be fairly lengthy because I'm going to do both days in one lesson video. So just be aware that it probably will be a fairly lengthy video. So let's take a look here at how we solve a polynomial inequality. First thing that we do is we factor as much as we can to find any zeros. And remember, zeros means that we would have our equation set equal to 0. So anytime it is not equal to 0, we need to make sure we take care of that. Then we use those zeros as critical points on a number line. And then we test points in between the critical points to determine which part we're actually going to shade. And then we express our answer in interval notation. So it's really not terribly difficult. Okay, so if we look here, we've got 2x squared plus 4x is less than 0. It's already set equal to 0. So if we factor it, we can take out a 2x out of both of them. We're going to have 2x on the outside, and we're going to have x plus 2. And we're going to use it as an equation right now, set equal to 0. If we set this first one equal to 0, we would get x equals 0. This one would be x equals -2. So these two values here on a number line, we are going to see what's happening. So we're going to make our number line. Okay, so we're going to put, obviously in order, we're going to have -2 and we're going to have 0. And if you notice that those critical points break the number line into 1, 2, 3 separate pieces. So what we're going to do is we're going to test a random number in each of those sections. Although first, I should probably go back and mention, just a little reminder from like Algebra 1, that this is a less than symbol, okay? Less than indicates that we would use an open dot on a number line, and it also means we would use a soft parentheses when we are doing interval notation. Okay, so just a couple things I wanted to remind us of. So if we wanted to test a point that's in the gray area, well, let's think about an easy number that would be less than -2. So we're going to test if x equals -3. And what we're trying to find out is if the inequality that we have there is true. So if we tried -3, okay, we're going to go back and we're going to use either one of these equations that we have. We could either use this one, or we could use this one. It doesn't really matter. I'll go back to the original one here. So if I go back, I'm going to say 2. I'm just going to show my work here, times -3 squared plus 4 times -3 is less than 0. What I'm going to do is actually I'm going to kind of separate these sections here so that you can see where our work is. And if we go ahead and simplify that, we get 2 times -3 squared. -3 squared is 9, times 2 is 18, minus 12, and then 18 minus 12 is 6. And 6 is not, in fact, less than 0, which means this is a no. We are not going to shade that section of our number line is not an answer. So then we move on over here to the pink section, okay? And the easiest number between -2 and 0 to test, if we're picking easy numbers, is going to be x equals -1. Well, let's put it back into our equation. So we are going to have 2 times -1 squared plus 4 times -1 is less than 0. Again, let me just kind of separate here so we can see our work. -1 squared is 1 times 2 is 2, minus 4 is less than 0, -2 is less than 0. So that is a yes. So we will be having that part as part of our solution. And then, again, let's try something really simple here off to the right. If we try a number greater than 0, let's pick 1. That's a nice, easy number. So we'd have 2 times 1 squared plus 4 times 1 is less than 0. 2 times 1 plus 4 is 6 is less than 0, and that's a no, which means the only part of our graph that's an actual would be true would be this section right here. And what we would have on our number line is we would have like an open dot, or we would have those soft parentheses. So when we go to write our answer in interval notation, so this is our answer on a graph. In interval notation, we would have just from -2 to 0. That's our interval notation to show which part of our number line is the solution. So there's our interval. Here is our graph with our work. Okay, so let's just look at a couple more different types of examples here. So if we have x squared is less than 9, that means x is going to equal plus or minus 3, because if we take the square root of both sides. So on our number line, we'd have x equals -3, and we'd have x equals +3. Okay, so let's draw ourselves our number line, and I'm going to make it nice and big because I like to show my work right there on the number line. So I'm going to have -3 and +3. Okay, and if you notice again, that kind of breaks our graph into 3 pieces, and it's less than, not, or equal to. So we'd have an open dot, soft parentheses. So this is going to be soft parentheses. Okay, so then we're going to take our original equation, x squared is less than 9, and we're going to pick a number to the left. So we've got, again, we have, here is part we're going to test, here is part we're going to test, and here is part we're going to test. Okay, so let's take a look here. If I want to pick a nice, easy number, less than -3, that would be on that gray part, I would say x equals -4. Okay, well, -4 squared is less than 9. -4 squared is 16. 16 is, in fact, not less than 9, so that's not going to be part of our solution. A number between -3 and +3, well, easiest number there would be if x equals 0. So for x equals 0, we would have 0 squared is less than 9, and 0 is less than 9, so that's going to be a yes. And then on the other side, again, let's pick an easy number. X equals 5. And if we say 5 squared is less than 9, 25 is not less than 9, so that's going to be a no. So the only part of our graph that's the actual solution is going to be this part. And since we have that less than sign on the graph, we would have soft parentheses, and our solution is going to be, in interval notation, it's going to go from -3 to +3. So there is our interval notation. And this part down here is our graph with our work that we use to figure out the answers. Okay, again, just doing a couple more examples here. Our next example, first thing we need to do is to make sure that it's set equal to 0 first. So I'm going to add 7 to both sides, and I'm going to have x squared plus 6x. If I add 7, I'm going to have plus 8 greater than or equal to 0. So this greater than or equal to means that we are going to use a hard bracket. That hard bracket means or equal to. Okay, that's because it has the little line underneath of it. So if we factor x squared plus 6x plus 8, we're going to have x plus 4 and x plus 2 equals 0, which means we're going to have x equals -4 and x equals -2. So when we go to do our number line, okay, we make a nice big number line here. -4 and -2, all right? We're going to have, here's -4 and here is -2. Again, we've got these 3 sections that we're going to test. 1, 2, 3. Okay, so again, I am going to go back up and I'm going to use, and again, it doesn't matter which of these two equations you actually use, but it needs to be the one that's set equal to 0. I am actually, I think, going to use the top one, the x squared plus 6x plus 8 for my test points. So I'm going to have, well, a number less than -4. Nice, easy one would be x equals -5. Okay, so if I plug that back into my equation here, if I plug that back in, I would have -5 squared plus 6 times -5 plus 8 is greater than or equal to 0. Let me kind of separate my area here. -5 squared is 25, minus 30 plus 8 is greater than or equal to 0. So I'd have -5 plus 8 would be 3 is greater than or equal to 0, which, yes, is a true statement. Okay, and then I'm going to go into my next section here. Between -4 and -2, really the easiest number to pick here is going to be x equals -3. So I'm going to go back. I'm going to say, go back to my equation. I'm going to say -3 squared plus 6 times -3 plus 8 is greater than or equal to 0. So I'm going to have 9 minus 18 plus 8 greater than or equal to 0. 9 minus 10 is -1, greater than or equal to 0. Oops, that is not true. -1 is not greater than or equal to 0. And then, easiest number I'm probably going to say that I would try in my blue section is going to be a number greater than -2. Easiest number anytime that we want to substitute would be if x equals 0. So we'd have 0 squared plus 6 times 0 plus 8 is greater than or equal to 0. And 8, those 0, 0, 8 is greater than or equal to 0, so that would be a yes. Which means our solution is going to be here. So this is -infinity. This is positive infinity over here. And these two sections right here are going to be our solution. So that means I am going to go from -infinity and at negative to -4. Remember, infinity is always a soft bracket. This or equal to right here indicates that we would need to have a hard bracket. So I would have a hard bracket there. And I am also going to be going from hard bracket -2 to positive infinity. And again, infinity always has the soft bracket. Okay? All right, let's do one more example here. I'm going to subtract 24 from both sides. 3x squared plus x minus 24 is greater than or equal to 0. All right, well, we're going to have to do some thinking over here because we can't just factor that really easily. We're going to have to think about our box method because there's a 3 out in front. So I need two numbers that multiply together to be -72, add together to be +1. Remember, this comes from 3 times -24. So those two numbers I would need to have would be 9 and -8. If I put those into my box, I would have 3x squared -24, I'd have 9x -8x. I put my 3x up here, my x there. I'd have 3x minus 8 and x plus 3. So my two solutions I'm going to have over here are going to be 3x minus 8 and x plus 3. So x is going to be 8/3, which is approximately 2 and 2/3. So it's between 2 and 3. And then our other answer is -3. Okay, so now I'm going to do my big number line down here. So I've got 2 and 2/3, and I've got -3. So here's going to be my -3. Here's going to be my 2 and 2/3. Okay, so again, we've got oops, I didn't want that color. I want to be consistent here. I've got my gray, I've got my red, and I've got my blue. And at those points, since it has the or equal to right here, that means we are going to use a hard bracket. Okay. The less than, greater than, without the line underneath of it would not have a hard bracket. That would be a soft bracket. So take a minute, pause the video, test a point in each of those areas and see which areas you should actually be graphing. Okay, so take a look. If you did it correctly, you should have shaded the far left and the far right, and then you would have a bracket at each of your solutions and infinity on both ends. Okay, so the next thing we're going to have to do is we're going to have to do some stuff where we find common denominators. Okay, so let's just remember how to do that. In order to add or subtract, you have to have a common denominator. So this is just going to be a quick review of how to do that. So if I think of this as a fraction over 1, in order to combine my numerators, I have to have the same thing in the denominator. Well, I have an x minus 3 in this denominator, which means I also have to have an x minus 3 in this denominator. But whatever I do to the top, I have to do, or excuse me, whatever I do to the bottom, I have to do the same thing to the top. So I'm going to have 5x plus 1 over x minus 3 plus, going to distribute here, 2x minus 6 over x minus 3. Okay, and now that I have common denominator, I can just, oops, daisies, I can just combine like terms in the top and get 7x minus 5. There's my 7x, there's my minus 5, over x minus 3. Okay, and let's just do a quick look at one more here. Okay, I don't think I need to do all 4 of them, but just a reminder that if you have a subtraction sign in between, I always like to just add the opposite. I've got an x minus 6, so I need to go x minus 6, or excuse me, x plus 6 on the top and the bottom. And I would have negative 7x plus 4 over x plus 6 plus negative 8x minus 48 over x plus 6. When I go to combine my like terms, I would have negative 15x minus 44 over x plus 6. Okay, so that's a quick reminder of how we actually find common denominators, because we're going to need to do that on a couple of these problems. Okay, so looking at these, if you notice the difference between the ones we are looking at here in this idea 2 versus the other ones was now we have a rational inequality where we have an x in the numerator and we have an x in the denominator. So our steps are going to be similar, but they're just going to look a little bit different. So the first thing we're going to make sure is that it's got 0 on one side. Simplify as much as you can. Common denominators add so that eventually you just have one term on the left-hand side. Find the value when when the numerator is 0, when the denominators are 0. That's your critical points. And then just like before, we just do a quick test in each of the areas to see what our solutions are going to be. Okay, so if you look here, we have one term, 4x minus 1 over x, so we do not have to find any common denominators. We don't have to set it equal to 0. That's already done. We have one nice, neat little term. And so really all we have to do to start, this one's a little bit easier, okay, as it says, so we are already skipping down here to step 3 and 4. Values when the numerator equals 0 would be 4x minus 1 equals 0, so x would equal 1/4. And then when the denominator equals 0 would be x equals 0. So we've got, here is our numerator, and here is our denominator. Okay, so now we have our critical points, okay, and now you're just going to do exactly what we did before. Our critical points are going to be at 0 and 1/4. Okay, and again, just like before, we've got 1, to 3 sections that we are testing. And again, paying attention here that greater than, there's no equal sign underneath, means that we will have a soft bracket when we go to finish up with our graphing and with our interval notation. Okay, so again, take a minute, pause the video, plug in values that you think would make sense, see which sections are actually going to work with this. And the fact that you have x equals 1/4 is not that big of a deal. You can pick numbers in between to test that are not fractions, so make your life as easy as you can, okay? So pause the video, go ahead and see if you can figure out which sections that are included in your solution and write your interval. Okay, so take a little look here and see if you got the same thing. The far left is a yes and the far right is a yes, and the middle section was a no. Okay, so then let's look at one that's a little bit more difficult. Okay, so I kind of made a mess here, so hopefully if you don't have that written down, you can. I'm going to go ahead and erase all of this to make a little bit more room for myself. Always can go back and rewind the video and get that information if you didn't. All right, so now we have a fraction and we have less than or equal to 3, which means we are going to have to do a little more work. So we're going to have to subtract 3 from both sides. So we'll have 2x minus 7 over x minus 5 minus 3 is less than or equal to 0 because I subtracted 3 from both sides. In order to, and let me move this over just a little bit. Okay, where are we at? We are at less than or equal to 0. I'm leaving out a little bit of space there because I want to be able to do my common denominator. Okay, so I have an x minus 5 in this denominator, which means I also need an x minus 5 in this denominator. Okay, so then we are going to have 2x minus 7 over x minus 5 plus negative 3x plus 15 over x minus 5. Let's put our factors together here. We would have negative 1x plus 8 over x minus 5 is less than or equal to 0, which means our critical points, my numerator is going to be, if I set that equal to 0, is going to be x equals 8, and my denominator is going to be x equals 5. Okay, so whoop, draw your number line. Here's 5, here is 8. And again, just like since we've done this enough times, go ahead and pause the video, test a point in each of the 3 sections. So test a point less than 5, test a point between 5 and 8, and test a point greater than 8. And then come back and double check that you get the same thing as me. Okay, so go ahead, double check what you have with what I have. I have that the far left from negative infinity to negative 5 is a solution, and notice I have a hard bracket here because of the or equal to in our original problem. And then I have a hard bracket here again that starts at 8 and it goes to positive infinity. I have one more example I'm going to do that ends up having 4 possible sections on the graph. So that'll be our last example that we will do today. Okay, so let's take a look here at our last example. All right, we have x squared minus 2x minus 8, so let's go ahead and factor that. We would have x minus 4 and x plus 2 over x greater than or equal to 0. So we don't need to find any common denominators or anything like that with this one. So if we set our numerator equal to 0, we would get x equals 4. We would also get x equals negative 2. And if we set our denominator equal to 0, we would get x equals 0. Which means we're going to have quite a bit on our number line here. So I'm going to make a nice, great big number line. And I'm going to have negative 2, 0, and 4. And again, now, instead of only having 3 sections, we've got 1, 2, 3, 4 sections that we are going to have to test. Okay, so I'm just going to tell you, kind of like the last time, to make the video a little bit shorter, I would like for you to pause the video, test a number in each of the sections and see where there's a yes and see where there's a no, and then write it in interval notation. Okay, so take a look here. So I did test points in all 4 sections, and I found that the red section and the green section were both solutions. I have hard brackets on each because I had an or equal to sign in my original problem. So I go from negative 2 to 0, both with hard brackets. And then I also go from positive 4 to infinity. And again, the infinity has a soft bracket on it in our interval notation because that's how it always is when we have infinity. So hopefully this was helpful, and good luck.